So today we're starting the polynomial operation section. This section starts off with a number of new vocab words that you're going to hear throughout this lesson and future lessons as well. That's how we're going to kick this off. We're also going to take a look at polynomial addition and subtraction today. So our first term is one that you should be familiar with already from our exponent rules section, and that's coefficient. And your coefficient is just that big number in front of your variable. So in this situation, you have the exponent of 3 here, but coefficient refers to the number that's right in front. So in this case, the 8. All right, now we've talked a lot about like terms, but just a plain term in general is your next term. It's just a part of any kind of expression that you have that's separated by either a plus sign or a minus sign. So in this expression that we have here, we actually have 1, 2, 3, 4, 5 terms. It's separated all by those adding and subtraction signs there. Okay, so multiplication doesn't count, so 11 and y squared aren't separate, for example. All right, the next one should be very familiar to you. This is in particular like terms. And remember, like terms are a little bit more specific than just any old terms. These are terms with the same variable and the same exponent. Okay, now we did an exercise similar to this at the beginning of our course, so this would be a great time to pause the video and try to identify pairs of like terms. I'll give you a hint, there should be 4 pairs of like terms. All right, so if you have paused the video and now you're ready to keep rolling, here we go. So we have 4x squared and negative 12x squared are like terms. That's because they have the same variable and that same exponent of 2. They don't combine with things like 6x or 1/2 x because they're missing that squared. But both of these only have an exponent of 1. All right, they also really wouldn't combine with 11y and negative 1y. These ones have the wrong letter, so that doesn't work out so good. All right, last but not least, we have just plain numbers that do count as like terms. So we'll do a couple triangles there as well. Okay, cool. So getting into some of the newer vocabulary, one of the first words that you're going to see a lot is monomial. All right, if you're familiar with the prefix mono, this is considered a polynomial with 1 term. All right, that means that you just have one little thing. Plain numbers and plain variables do count as monomials, or you could have something as crazy as this that has all these different variables going on, but if there's no addition or subtraction in the middle, it still counts as all one thing. Where we do start getting multiple terms is for something called a binomial. Again, if you're familiar with the prefix bi, that's going to mean 2. So in this case, you have a polynomial with 2 terms. So in this case, you will see some addition and subtraction in the middle of your problem that separates this into 2 pieces. So some of the ones that we'll see a lot here in the future are things like this and things like this. That'll come up in our factoring section. You can still use fractions and decimals in this case, even though they don't come up all that often, they are still fair game. All right, the next kind is a trinomial. And keeping with the trend here, this is a polynomial with 3 terms. All right, this kind here will be very popular coming up in our next unit. But you could have multiple variables. You can have a coefficient out in the front too. They can really look however you want with any combination of plus and minus in there. Now, if this section is called polynomial operations, we do need to define what a polynomial is. Okay, in more easy to understand language, it's just an expression with many terms. Only 1, 2, and 3 have the special names monomial, binomial, and trinomial. Anything beyond that is just considered a polynomial. Now, your textbook definition would call it a monomial, or the sum of monomials. So it's just basically saying that you could have 1 term or more than one term that are positive or negative, but they're all being combined together. So really, all of the things that we looked at, monomials, binomials, trinomials, and any number of terms beyond that counts as a polynomial. Now, some other calculation-y kind of things, not really, that go with polynomials is something called the degree. Degree will get really important in Algebra 2. We don't do a whole lot of it here in Algebra 1, but just so you've seen it before you move on to your next math class. A degree is the highest exponent value in your polynomial. So if I'm looking through all of these terms, again, I have 1, 2, 3, 4, 5 terms going on here. I'm looking for the one with the highest exponent. In that case, that's going to be this guy. Now, when I go to establish and write down my degree, I don't want to write the whole term. So I'm not going to write negative 4x to the 5th. All I'm worried about is the exponent. So if I were to describe this using degree, this polynomial would be degree 5. Just because 5 is the highest polynomial value. Okay, again, we won't do a lot with that here in Algebra 1, but degree becomes very important in Algebra 2. It gives you a lot of information about your polynomial. One thing that we will apply in our answers is something called standard form. And it's basically just taking your polynomial and putting it in order. And to make sure that it's in order, we're going to go from highest to lowest exponent value. Some people have a natural eye for standard form. Like for me, this feels out of order to me. So what you want to do is go from the highest exponent term to the lowest exponent term. So this is the same polynomial from our degree conversation. So I know that negative 4x to the 5th has the highest exponent. So that is the term that would actually be written first. From there, I want to scan through. The next highest exponent is the third one here, the third power. So I want to make sure that I also keep that sign just like I did for the negative 4x to the 5th. That comes along, and that's how I'm going to connect these two. So minus 7x to the third. My next highest exponent is here that's squared. I get some people who tell me that this is the one that has the highest, that's the biggest and should go first because of the coefficient. But again, we're looking at the exponents only. All right, the next one is just going to be the plain x, so minus 12x. And your plain number technically has an x with an exponent of 0 on it, but the plain number just goes in the back. All right, both of these polynomials are equivalent. They're exactly the same, just this one is in order, and that's the more widely accepted format. All right, now that we've talked about our vocab, we're ready to move into polynomial addition and subtraction. Okay, so addition is as easy as combined like terms for the most part. It looks a little bit fancier with all of its parentheses and terms going on, but really if you can combine like terms, you can definitely be successful at polynomial addition. So the first thing that we're going to do is remove our parentheses. Because we're adding, they aren't really going to change much and they aren't really doing anything. You can think of it as a positive 1 right here and distributing a positive 1. But if you distribute a positive 1, again, things don't really change. And that's the same out here. You have a positive 1 that you could distribute, but it doesn't really change anything. So we're pretty much just going to rewrite and drop those parentheses. What's going to happen after that is we're just going to identify and combine like terms. Those were those terms with the same variable and the same exponent. So I'm going to start by rewriting my polynomial without parentheses. Now, as you practice polynomial addition and get more comfortable with it, you can often start skipping this step and just start combining and identifying your like terms from inside those parentheses. Now that it's less helpful for subtraction, so just be careful. I'll talk to you through those ideas in the next section here. All right, so now that my parentheses are gone, I want to identify my like terms. So I see a 10x to the 4th here out in the front. I want to look for anything else with an x to the 4th. Looks like I have one way back here, minus 4x to the 4th. And that's actually how I'm going to combine them. I'm going to keep that sign there. So even though this is considered polynomial addition, you might not actually add your terms. Technically, I'm taking 10x to the 4th and adding negative 4x to the fourth, which will in action work like subtraction. So just keep that in mind as we go forward. All right, we have 4x squared and 2x squared. Both of those are positive. And we also have negative 10 and positive 14. All right, so I'm gonna go ahead and combine those like terms. So 10x to the fourth minus 4x to the fourth will make 6x to the fourth. 4x squared and 2x squared will make 6x squared. And negative 10 plus 14 will make positive 4. So after you combine, that's what dictates your signs in between each term. And I don't have any more like terms to combine. I'm in standard form going 4, 2, and then no exponent. So this makes my absolute final answer. Okay, on the next example, we're going to do the same thing. We're going to drop those parentheses. And again here on the second set. Now be careful, you do have plus minus, which will end up treating like minus. Okay, again, we're gonna go through and we're gonna identify our like terms. Now I have 3x to the fourth here in the front, and if I look through, I actually don't have any other x to the fourth terms. So this one is just gonna come down as part of my final answer. All right, after that, I have x to the third, 5x to the third, and negative 7x to the third, which should make negative 2x to the third when I combine them. 5 minus 7 will make negative 2. I'll have a negative 2x squared and a positive 11x squared. So let's see here, negative 2x squared plus 11x squared will make positive 9x squared. And it looks like I have one unpaired term out here on the end, and that's a positive 4x. All right, it looks like my terms again ended up in order. We have a 4, 3, 2, and then an exponent of 1. I don't have any more like terms that I can combine, so that means that this is our final answer. All right, one final polynomial addition example. I'm again just going to drop those parentheses. And if you're feeling comfortable, you can skip that step and just go ahead and start combining like terms. All right, as I go through and identify, looks like I have a 10, a 2, and a positive 7 out here that will all combine. It is okay to have more than just a pair of like terms. So here we have a group of 3. If I do 10 plus 2 plus 7, 10 plus 2 will be 12, and 12 plus 7 will be 19. All right, next I have a positive 3x, and looks like a negative 3x out this way. Now remember, positive 3x and negative 3x will make 0 x's. And if you have 0x, we don't write anything from that term. So these two actually cancel each other out completely. I do have one more set of unpaired terms here. We have a negative 8x squared and a positive 12x squared. And when I combine them, I'm going to get positive 4x squared. Now, although my answer is technically correct, it is not in standard form. So just to help you build good math habits, we're going to rearrange that. So we're going to put the 4x squared in the front. No symbol out here because it is positive, so it's implied that there's like a plus in the front. And 19 is positive, so I'm going to go ahead and put a plus sign in the middle. So again, both those answers are equivalent, and this answer here is technically not wrong. It's just not in the best format. And that's polynomial addition. Now, polynomial subtraction will be very similar. So if combining like terms is still a good thing for you, polynomial subtraction will also be a-okay for you. So it does have a different first step, and that's to distribute a -1. And what that's going to do for us is it's going to remove those parentheses and take care of the subtraction portion of this. So if you noticed up here in my addition problems, you can tell in the middle that we're adding because of the sign. Similar deal here. I can tell that I'm subtracting because of that sign in the middle. But like we've said in class, negatives don't just float around. There has to be a -1 that it's attached to. So that -1 is going to get distributed only to the things that are behind it. This one still technically has a positive 1 that's being distributed, but again, that first set isn't going to change. Multiplying by 1 isn't going to do anything. So in the first one, I'm going to go ahead and bring down this first term and the second term and that third term just the way that they are. All right, after that, on the second trinomial there, I'm going to distribute that -1. So this will turn this into a -7x to the 6th, a positive 11x to the 4th, and a -3x squared. And that comes from, again, distributing that -1 to each of these. The numbers don't really change. It's really just flipping those signs in the second set. Some people like to think of it that way, and when they rewrite, they think of it as flipping all of these signs. All right, our second step is the same as in polynomial addition. We're just going to identify and combine like terms. So I'm going to go through and check out what I have. I have 4x to the 6th and -7x to the 6th, which will make -3x to the 6th. So 4 minus 7 makes -3. I have -2x to the 4th and positive 11x to the 4th, which when combined will give you positive 9x to the 4th. And we have positive 10x squared and -3x squared, which should give me positive 7x squared as my final answer. Everything is in order in standard form. We have 6, 4, and 2, and no other like terms. All right, just so you can see that one more time. Here, normally, without anything really special, we have a -1 there that we will distribute to the second set. We'll rewrite this first term, and the second term and the third term. And then we're going to distribute that -1. So this will turn into -7x to the 4th, a positive 2x to the 3rd, and a positive 5x squared. And then from there, it's combining like terms. Now, when we were doing polynomial addition, we were able to combine like terms straight from the parentheses, which you could do here as long as you always make a pit stop at that minus sign in the middle. So I would have to think of this as 7x to the 3rd minus -2x to the 3rd, which is going to work like 7x to the 3rd plus 2x to the 3rd. So in doing the distribution, we kind of remove that pit stop that's needed. But if you feel comfortable, just making sure that you touch on that minus sign in the middle between each term that you're trying to combine from this set and this set, then you could still be successful. All right, 7x to the 3rd plus 2x to the 3rd will make 9x to the 3rd. I have -8x squared and positive 5x squared, which will make -3x squared. I have -4x, which is actually not a like term with -7x to the 4th. So I'm going to go ahead and put down -4x. And then separately we'll have -7x to the 4th. So although, again, this answer is perfectly acceptable, it's not wrong, we're going to rearrange it to put it in standard form. So -7x to the 4th is my term with the highest exponent. After that will be 9x to the 3rd. Minus 3x squared, minus 4x. This is the best answer. All right, we have a couple kind of weird things that happen here in this next set. I do have a -1 that I'm going to distribute. And we're going to bring down the first trinomial. No sign changes here. And we're distributing a -1 here on the second set. Again, that should adjust those signs and take care of the subtraction aspect of the problem for you. Okay, we're going to go ahead and combine like terms. We have 5x squared and 2x squared, which will make 7x squared. Here's our little weird chunk where we have a positive 6x to the 3rd and a -6x to the 3rd, which should cancel out. Again, I don't put anything there in my problem. The last chunk here is a positive 5x and a -4x. Now 5 minus 4 makes 1. So technically I have a 1x, but remember, when I see these in action, I'm not going to see that implied 1 there. So this is already in standard form, so I can keep the order okay, but I am going to drop that implied 1 in front of the x. So this would be the answer that you'd be most likely to see, say, in a testing situation. All right, if you're feeling groovy about polynomial addition and subtraction, now's a great time to pause the video and try out this addition problem and this subtraction problem. All right, if you're ready to check your answer, here's what you should have. Your final answer for the first one should be 15x to the fourth plus 12x squared plus x. If you left your 1 in front of that x, that's also okay. It's also okay if your terms are out of order. It is best to put them in standard form, but as long as you have the right pieces with the right sign, you technically have the process down, which is the most important part. For the subtraction problem, your final answer should be 2x to the fourth minus 3x squared plus 4x minus 7. Again, if your order is different, but you have the right signs and the right numbers, then you're doing A-okay.